In this example, we're asked to consider the differential equation dy dx is equal to x divided by y. And we're going to use that to answer the following questions. Part A wants us to sketch a slope field for the equation on the axes below. So just remember that our differential equation dy dx is equal to x over y when we do this, and that'll help us to find the slopes of these lines. Now, one thing to mention is that when y is 0, dy dx is undefined. That doesn't mean that we should draw a vertical line when y is 0. What that means is dy dx doesn't exist, or the slope of the tangent line doesn't exist. So if that slope doesn't exist, then we can't actually draw any line when y is 0. So our x-axis here will not have any little lines on it, because there on the x-axis that value is for y is 0, and that causes dy dx to not exist. Let's just start on the upper left-hand side. You can start at any point you really want. So we're going to start right here at -2, 3. So if I think about this, I've got -2, 3, and the slope then would be -2/3. So I'm going to try to draw that here as having a slope of -2/3. So let's see here. That would be maybe something that looks like this. At -2, 2, I could take -2 divided by 2, and I would get a slope of -1. At -2, 1, -2 divided by 1 is -2. So my slope would look just like this. If I continue on here, I've got, if I keep going below the x-axis, I have -2, -1. So that slope should be +2. So I'll try to draw a +2 slope line right here. And then if I keep going, I've got -2, a -2, so that slope would be 1. And then -2 divided by 3, so that would be -2/3. So it's going to look just maybe a little bit like this right here. And then I'm going to begin a new column, and we're going to keep going there. So I've got, let's see here, -1/3. So that would be a slope of -1/3. So kind of shallow, just about like that. And then at -1, 2, I'm going to have a slope of -1/2. So that might look a little bit like this. And then I've got a slope here of, let's see, -1 divided by 1. So that's -1. So my slope will look kind of like that. And if I keep going below the x-axis, -1 divided by -1 is +1. So this point should have a slope of 1. Here I have -1, -2. So that'll be a half. So that'll look like it kind of shallows out a little bit. Maybe something like this. And then I'll have -1 divided by -3 here. So that'll be a slope of 1/3. On the right-hand side, we still need to do the y-axis, so we'll do that first here. So on the y-axis, the x value is 0, and other than y being 0, 0 divided by any number is 0. So I'm going to draw those horizontal lines right here. Notice I'm not going to draw anything at 0, 0. 0 divided by 0 is undefined. We don't really know what that is. So there's no slope there. And as we continue on the right-hand side, here I have 1/3, which should just be the opposite of the slope when x was -1 and y was 3. So you're going to see this kind of look like a little bit of a mirrored image here as we go. So I'm just going to go ahead and try to draw those as best I'm able. So I'm looking at the left side of the y-axis, and then we'll look at the right side as well. So here my slope should be a half. And then over here, my slope should be 1. And then I've got another slope of 1 right here. And then I've got on the right-hand side here, it should have a slope of 2. And I can do the same thing for the ones on the bottom. So we'll see how that works. And that'll be a slope here of -1. And then a slope here of -2. And then we're going to have a slope of, let's see, that's going to be negative 1/2. And then we've got a slope here of, oops, that should be -1. So let me erase that. And we'll do -1 here. Oh boy. And the slope here is right 1 down 3, so that'll be 1/3. So that slope should be -1/3. Actually, it's 1 -3. So I'll try to draw a slope here, nice gentle slope of -1/3. And then we've got right 2 down 3, so -2/3 would be the next slope. And I can draw that just about like this here. So we've got part A done. And then part B says sketch a solution curve that passes through the point 0, -1 on the slope field. So let's go back down to the slope field and let's see, 0, -1 is right here. So I need to include that point on my drawing. And what I'm going to do here is I'm going to try to draw this. And this part might not work out great. So this part should have been maybe a little bit steeper right there to match that tangent line. And then I'm going to draw something that looks maybe like this here. So it's kind of looking like a parabola, maybe hyperbolic, something of that sort. Now we're going to do this at a later time, but we can go through part C if you'd like. So part C says find the particular solution, which means the equation that has dy dx being x over y, and then also passes through that point 0, -1. So we're looking for a particular solution. Initial condition is here. So the very first thing to do is to separate our variables. So we're going to multiply by y on each side and multiply by dx will be the next part. So I'm going to multiply by dx on the left and then multiply by dx on the right. The dx's on the left will cancel, leaving us with y and dy on the left. So I can write that down. I've got y times dy. And then on the right-hand side, I'll have x times dx. And we need to have that set up first. The variable and the variable in the differential needs to be the same. We're going to integrate each side, find the antiderivative. So here we've got y squared over 2. Here we've got x squared over 2 plus c. We just need the c once. And now I'll substitute my point in. So my point is 0, -1. So I'll have -1 squared here over 2 is equal to 0 squared over 2 plus c, which then means that c is 1/2. So this guy's gone. 0 squared over 2 is 0, and c is equal to 1/2. So then what we'll do is we'll take our equation that we came up with before, right after we found the antiderivative, and we'll write y squared over 2 is equal to x squared over 2 plus 1/2. Now we can multiply everything by 2, and we'll have y squared is equal to x squared plus 1. And just to top this one off, we could subtract x squared from each side. Y should be connected a little bit better there. That's supposed to be a y as well. So we've got y squared, and that symbol, I don't know what that symbol is, but we'll write our minus sign, is equal to 1. So the particular solution for this happens to be y squared minus x squared is equal to 1, and that is the graph of this guy right here. Now, in that equation, there'd actually be another branch that would be up on the top, but for our solution, the best we could do earlier is just draw the curve that's listed here, and then if we actually found that particular solution, part C, we wind up getting y squared minus x squared is equal to 1.